Okay, so last section for this week also, I think this is going to be the last section in chapter 9, 9.4. It's on conic sections. There's 4 basic conic sections. We really end up studying 3 of them. The 4th one we've kind of been studying all year, and when I show you what it is, you'll know. So conic sections are basically the different ways that you can take a cone, slice it, and look at the cross section. Right? If you take a cone and you slice it straight across and then look at the end, you'd have a circle. Okay, that's the circle. Now, if you do kind of the same thing, but instead of slicing the cone straight, you slice it through on an angle, that's where you get an ellipse. But when you slice it as an ellipse, you still go through the sides of the cone. Okay? When you slice it at enough of an angle that all of a sudden you come out the bottom of the cone, you get a parabola. Right? So I think the ellipse and circle, it's kind of easy to visualize. Parabola is a little harder, but if you did cut the cone off right there, like almost cut off the side of it, the shape you'd be left with is a parabola. And then the hyperbola, that one's a little different. That one's where you got to put 2 cones back to back, okay, with the vertices connecting, and you slice it straight down. And with that, you get 2 shapes. They're actually called branches. Right? You get 2 separate branches of the parabola, and they're mirror images of each other. One's like a U shape, and the other one is an N shape. So even though ellipses and hyperbolas don't look anything like each other when you look at them, the equations and the formulas for them are almost identical, which can kind of be confusing because they're so similar. You have to remember, wait, is this the one where you have the plus, or is this the one with the minus? And then like, everything else in the formula is the same. But we're going to focus just on the parabola today. All right? But those are your four different conic sections. People remember studying those maybe at the end of Algebra 2? Yeah. A little bit. So parabolas have a lot of vocabulary with them, so we're going to talk about some terms first. There's 4 different kinds of equations for parabolas, depending on if it opens up, down, right, or left. Parabolas can open 4 ways. We'll go through one of them in detail, kind of where the equation comes from, and to get all the other ones, we'll just look at the pattern that the first one gives us. All right, so every conic section starts out with the definition, and the definitions pretty much start as a collection of points that meet some criteria. A circle would be the easiest one to describe. A circle is a collection of points that are all equidistant from the same point. It's a circle. Okay? Take a bunch of points that are all the same distance from a central point, and you've created a circle. Parabola is a little more complicated. There are some things that are equidistant, but it's a little more complicated. It's a collection of points, and we can call that collection P. So all the points. All the points are the same distance from 2 things. So if you measure a distance from any point on the parabola to this, and the distance from that same point to that, it's the same. So I'm going to tell you what the 2 things are. One of the things that you can measure the distance to is a fixed point somewhere. The other thing you measure the distance to is a fixed line somewhere else. Okay? And I'm going to show you this as a picture. So it's going to be a lot easier in a second to visualize this. Right, so I'll come right back to that, but let me show it as a picture and then we'll come back. So here's a parabola. Okay, this is the case where the parabola opens down. Okay? Don't worry about the equation right now. B is a point on the parabola. Okay? A is a special fixed point. That's what I am referring to as F. Okay? It's a special point that the parabola kind of wraps around. Okay? It's not a point on the parabola, it's in it. line DE. That's the special line that I'm talking about. So these two boxes, these are actually calculations. Okay? They'll change. I don't want to do that. But they will change the number as I drag things around. So I'm going to measure the distance from the point on the parabola to that special point, which we're calling it A, but I'll tell you what it's called in a little bit. And then I'm going to measure the distance from B up to line DE. Okay? Always measuring perpendicularly. So watch what happens as I drag point B. No matter where I drag point B, the distance from B to that special point, A, and the distance from B to the line at the top, it always stays exactly the same. Okay? No matter where you put the point on the parabola. So if you move it, it's easier with a mouse. I move it over here, still stays exactly the same. So that's the definition of a parabola. Collection of points that are equidistant from a special point there and a special line up there. Any questions on that? Okay, now I'm gonna name what those things are. The special point that was inside the parabola that the parabola wrapped around is called the focus. It's the focus of the parabola. That special line that was running left to right above the parabola, that was called the directrix. The focus is always inside the parabola, and the parabola wraps around it. Also, the parabola always bends away from the directrix. The parabola and the directrix never cross. Okay? Parabola bends away from it. Okay. Any questions on that? So if you may or may not study like parabolic reflectors in physics, but a lot of times on car headlights, what's behind the headlight, it's not just flat, it's parabolic. So what happens is maybe like right here, you've got a light bulb, and sometimes there's a covering over the front of the light bulb. So when you look at it, you're not actually seeing any of the light directly from the light bulb. It all bounces off the back of that reflector, and then it goes straight out, because that's what a parabolic reflector does. It'll take anything that hits it and reflect it straight. So no matter what angle it hits at, all the rays bounce out parallel. And that's what you want for a headlight. You don't want the rays like shining up in the sky. You want them all pretty much going straight. Satellite dish is just like that in reverse. Satellite dish receives signals. So signals might bounce in from different directions, and they get focused to one point on the satellite dish. Usually there's like a little, I don't know what you call it, but there's like a little thing right in the middle of the satellite dish, and that's where the wire connects. So a lot of times if you look at a satellite dish, it has a curve to it. It's usually a parabola or a parabolic curve. All right, so if you look at, in your packet, figure 3, and I think I have this on the board in a little bit, yeah. But figure 3 is basically showing us this. What's in that box is exactly what I just said in all those words. That if you measure the distance from the focus to any point on the parabola, and the distance from that same point to the directrix, they always come out the same. So, same equals. That's what that is. They always come out the same. And figure 3 shows that. I'm gonna kind of draw. I'm gonna focus on figure 4, but if you want to look at that in figure 3, that's kind of what they're showing. Okay, but just remember that equation. That's what's going to be important. Okay, just summarizing this whole idea as an equation. So if you draw a line through the focus and perpendicular to the directrix, that's called the axis of symmetry. Right, so if I had, let's go like this. All right, so I'll just draw my parabola. There's a way to figure out exactly where the directrix would be. Just know that it bends away from it. Here's your focus. Well, if I draw a line through the focus, make sure it's perpendicular to the axis of, make sure it's perpendicular to the directrix. You just drew the axis of symmetry for the parabola. Okay. So right through the focus, perpendicular to the directrix. Okay. Where the parabola and the axis of symmetry cross, the spot that I just circled in red, that's called the vertex. So for a parabola, the vertex is either the highest point, the lowest point, the furthest left, or the furthest right point. Depends on which way it faces. In this case, the vertex is the highest point. Okay, and there's one other term that they mention, and if you see it in the homework, you don't have to worry about finding this. Like they're going to talk about finding what's called a lattice distance. You don't have to worry about that, but I just want you to know what the term means. It's pretty simple. The lattice distance, or your book calls it the lattice rectum. I don't know why, but that's what they call it. It's the width of the parabola. It's the width of the parabola, but not just anywhere, because the width of the parabola is always changing. It's always getting wider. It's the width through the focus. That's all that it means. It's the distance right through the focus from one side of the parabola to the other. Okay, so again, if you see the directions in the homework that say find the lattice distance, they're probably going to say find several things in the problem that I'm going to talk about. Like find this, find this, find this, and find the lattice distance. Don't worry about lattice distance. It's not that hard. It really just involves finding two coordinates and using the distance formula. But we don't have to worry about it. All right. So I told you there's how many different equations for a parabola? There's 4. I'm going to show you where one of them comes from. They could all be figured out exactly the same way I'm going to do this one. But we're only going to do one of them, and then the rest of them I'm just going to give you in a list. I'm going to assume the simplest case first, where the vertex is at the origin. Can you translate a parabola up, down, left, or right? Yep. But for now, let's not do it. Just leave the vertex at the origin. And the focus is going to be on the positive x-axis. So think about that. If your focus is going to be on the positive x-axis, and the parabola has to wrap around the focus, which way is this parabola going to open? And the vertex is right here. Yeah? It has to open to the right. So what we're looking at now is we're going to figure out the equation when the parabola opens right. Alright, so let's going to move some stuff out of the way for a second. So what I've drawn here is basically that picture I drew in red, but I drew it a lot nicer. So I've got my xy axis. I've got my directrix. That's not really part of the parabola. That's just a dotted line that the parabola bends away from. I put my focus. I labeled just a point on the parabola somewhere. It doesn't really matter where you put it. I would just put it up somewhere around there. And right now, that's all I have. So it's just parabola, and the focus has a coordinate a comma 0. I don't know what a is, okay? It's a positive number. I don't know how big of a positive number, but I do know the y value is 0 because of what they said in the directions. Assume the focus is on the axis, which means the y value is 0. Any questions on that picture? All right, now we're going to draw some things out. We're going to end up with some triangles in it. All right. So let's go back and look at the equation. The distance from the focus to any point on the parabola. That's right here. Actually, I got it right here. The distance from any point to the focus equals the distance from that same point to the directrix. All right. From that point to the directrix. So that means this line segment and that line segment are the same. That's the definition of a parabola. Okay, and that's what I tried to show you in that program. It's called Geometer Sketchpad. You can sketch different stuff. All right. Now, what I want to do is make a triangle out of this. Okay. The way I'm going to make a triangle, because my goal eventually is I want to find the length of this. While it's kind of on an angle, so it doesn't go straight up and down, it doesn't go left and right. Anytime I have a line segment on an angle, you've got to use Pythagorean Theorem to find out how long it is. Okay? This one, I don't need to do that. That one goes perfectly left and right. So I can find the length of that easy once I put in some labels. Okay, so here's a vertical line coming straight down from the point to make that segment, we'll call it segment PF, to make that a hypotenuse. All right, now let's label this distance on the bottom right here. How long is that segment that I just drew? We've got enough information labeled up there that we can maybe not give it a number, but there is a letter that would represent how long it is. Yep. Yeah, it's A. How do you know that? Because this point is at A0. So to get from the origin to here, you went A units to the right. So this is A, from here to here. Now, it's a little tricky for me to squeeze it in, but I want to now label this distance in green. And that I know too. And my hint to figure that out is, think of this rectangle right here. That's a rectangle. If you know the top side of the rectangle, how long that is, how far over you had to move to get to this point, the top side and the bottom side are exactly the same length. So anyone think they know how long the bottom side of that rectangle is? Yeah, it's x. How do you know that? This is 0 on the x-axis, or it's straight up from the origin. So you're at 0. You went to the right x units to get to point P. So that means the bottom right there is also x. Why is that important? Because in a second, I really want to know that. And if I know the red and I know the green, I can do something with A and X to get the part in blue. Right? That's probably the hardest part. How about the height of that rectangle? I've got enough information that I know the height of the rectangle, which is also the height of my triangle. Yep. Yep, that's y. All right. So there's y. All right. How about this distance right here? What would that have to be? Think about this point. What's this point right here called? The furthest left that the parabola goes? It's the vertex. Is the vertex a point on the parabola? What do you think? Yeah, okay. Yes, the vertex is a point on the parabola. We just said that if you have any point on the parabola, including the special one called the vertex, the distance from that point to the focus and that point to the directrix is the same. I'm asking you about the distance from that point to the directrix, but we already know the distance from that point to the focus. So how long is that segment in there? Yeah. It's also A. 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 All right. So now let's set up our equation. The distance from the point to the focus equals the distance from the point to the directrix. But I want to fill that in with our labels. Let's start with the distance from the point to the directrix. That one's easier. Okay. I want to know how far it is from here to here. Okay, that segment in blue at the top. That is going to be that, the distance from the point to the directrix. The way you figure out the length of that segment on the top is to think about it in two sections. Think about the distance from here to here, which we know, and then the distance from here to here, which is really just part of another rectangle right there. So how long is this segment? Let's just go from there to there, that top blue part, yeah? A. And how about this part? Yep. It's x. So that distance is A plus x. Now, technically, this A right here, it's going left, so it might be negative. If I want to make sure, because it's a distance, make sure I always get a positive number, what can I put around it to make sure negatives go away? Yep. Absolute value. So let's just call this x plus A and make sure we take the absolute value. That's the distance from the point to the directrix. Point to directrix. Now, I want to find this. Distance from point to focus. Point to focus. That bold line in black. That line in black is the what in that triangle? Yeah. It's the hypotenuse. And we know the lengths of the other two sides. So we know the green side and we can get the blue side. What theorem can you use when you know 2 out of 3 of the sides to get the third? Madison? Pythagorean theorem. Yeah, we can use the Pythagorean theorem. All right, let's start with the easy side. What's the height of the triangle that has the black hypotenuse? Y. Okay, so that's the easy one. So we got y squared plus. Now I need the length of the base. That's the part in blue. But remember, you know the part in red, you know the part in green. How would you get the part in blue? Yep.
A minus x.
Yep. So the length of the blue is a minus x squared. And now to find the length of something, take the height squared plus the base squared. And what else do you have to do in the Pythagorean theorem? Yes, take the square root. And now once we solve that, we're going to get a ton of stuff that simplifies, and then we'll get the equation for a parabola. In fact, most of it cancels out. I think you're only left with 3 things when you're done. All right, to solve this, the first thing you have to do is get rid of that square root. You can't start doing any of this stuff out till you get rid of what's protecting everything under the root. So what would you do on both sides to get rid of the root? Square it. Y squared plus a minus x squared equals.
You didn't put the squared on the line.
Thank you. That would be a problem. Equals. Now, how come I did that? I thought we needed absolute values to make sure it came out positive. I mean, I could put in parentheses the absolute value of x plus a squared, but you don't need that. Yeah.
When you're squaring something, it's always positive.
Yeah, when you square it, it's going to be positive anyway, so you don't even have to worry about if it was negative. Now it would be positive. Now we'll do these out. So y squared plus, what do you get if you FOIL out a minus x squared? What would be your first term? A squared. And now do your outer and inner. A times negative x, and then another a times negative x. Positive or negative?
Positive.
Well, it's a times negative x combined with another a times negative x. So negative 2ax. And what about your last term? X squared. Positive or negative? Positive. Now FOIL out the other side. When I do that one, what's my first term? X squared. What would be my middle term? Positive 2ax. And what about my last term? Plus a squared. Now, I know there's some like terms I can move from side to side, but does anyone see something I can subtract on each side first? And it would cancel out. Yeah?
The 2ax.
That's something it's not going to cancel out, but I can move it eventually. I'm going to do that in a minute. I just want to cancel out whatever I can first. Yep.
A squared and x squared.
Subtract a squared. Subtract a squared. Gone. Gone. Subtract x squared. Subtract x squared. Gone. Gone. And I'll do what Natalie said at the same time. Add 2ax. Add 2ax. Gone. So the only thing on the left now is y squared. What's on the right?
2.
We had a 2ax and we put another one with it. So 2 plus 2, 4ax. So after that kind of complicated picture, you get kind of not of a bad formula. It's not really that bad. Y squared equals 4ax. So that's the equation of a parabola with the vertex at the origin. And the focus is a comma 0. In general, and I think I write this later on, the focus is always a units away. It's always a units away from the vertex. That's always the letter they use. Since a is measuring a distance, it's always going to be a positive. Especially because our parabola is opening to the right. There's no way the focus could ever be in the negative part, no matter how wide or narrow the parabola is, because the parabola has to wrap around the focus, so it's got to be to the right. Okay. So that's the first equation. Y squared equals 4ax. Graphing a parabola, it's not really that hard. Easiest thing to do, really important, is finding the vertex. The focus is more of an imaginary point it's going to wrap around. The directrix is an imaginary line it bends away from. So if they ask me to find them, I will. Do I really need the focus and directrix to graph it? No. I need the vertex though. And then what I usually do is once I have the vertex, find two other points. Like, let's say, this one's a little more pointed, but let's say this is your vertex. Okay, this is your focus. If my parabola opened left or right, to get the correct width, I would probably try to find a point above and a point below. If I could find those 2 points, then I've got 3 good points to draw my parabola. Now, if the parabola opened up or down, once I had my focus, I would find one left and right. Left and right. And that just gives me a nice set of 3 symmetrical points to get an idea of the width. All right, so I'm not looking for it to be perfect. If you do 3 points, that's enough to draw. Okay. Okay, let's look at an example. So find an equation of a parabola with a vertex at the origin, and the focus is 3, 0. So here's your equation. The only thing you have to figure out is A. In the final answer, y is going to stay right where it is. X is going to stay right where it is. Just solve for A. Now remember, A is the distance between focus and directrix. So they didn't directly give you A, but, I'm sorry, focus and vertex. They didn't directly give you A, but they gave you enough information to find A. How far apart is the focus and the vertex in this problem? They're 3 units apart. So in this problem, A is right there. A is 3. Okay. So y squared equals 4 times 3x, or y squared equals 12x. That's your equation. Okay, so you had to figure out A. And that's all you need to make the equation. Any question on that? Okay, now let's graph it. So vertex is 0, 0. Okay. Since y is the letter that's by itself on the left, I'm going to pick a value for x, plug it in, and see what I get for y. Now you could pick a lot of different numbers for x, but if you pick one that I'm thinking of, it's going to make the calculation easy for me to do in my head. What could you let x be? You're going to have to take the square root next. Yeah?
3.
3. So let's let x be 3. If x is 3, 12 times 3 is 36. Y squared would equal 36. So what would y be? 6. Or negative 6. So if you plug in 3 for x, you get y squared equals 36. And y equals plus or minus 6. That plus or minus is where you're getting the symmetry from. So right 3 up 6. Right 3 down 6. You see a parabola, I don't know. Kind of looks something like that. Good enough. And where was the focus? 3, 0. So if the focus was 3 units to the right of the origin, where would the directrix be? Remember, this point has to be the same distance from the focus as it is from the directrix. Yeah?
3 units.
3 units which way? Left. Right there. That's where your directrix would be. The vertex has to be halfway between the focus and directrix, always. That's the definition. They didn't really ask us to put the directrix in on this one, but I'm just showing you where it would be. If you got the sketch and you got the equation, that's all you need. Okay, let's look at this one. This one just says discuss. You don't have to draw it. Now, it's not in the right format. Okay? The format is y squared equals 4ax. So now you've got to work backwards to figure out what would a have been. 2. 4 times 2 times x. Now you know a. Okay? So far, where has the vertex always been for every problem we've done?
Origin.
It's always been at the origin. You'll know when it's not. Now the focus is, let's go back to what I said right here. The focus is a units away from the vertex, right? We know that this one opens to the right. It's the only one we've done so far. So if the focus is 2 units away, and it's 2 units right, where would your focus be? Yep.
2, 0.
Your focus would be 2, 0. I kind of already gave this one away to you. Which way does it open?
Right.
It opens right. And where would the directrix be? If you're not sure, you could make a quick sketch. Here's your parabola. There's your vertex. There's your focus. Directrix has to be right there, which would be at -2. And it's a vertical line. So x equals -2. Okay, so that's an example of a discuss. When I ask you to discuss, I just want you to describe those 4 things.
I'm confused on how you got direction.
How we got the directrix? Well, the directrix has to be the same distance between the directrix and V. That has to be the same as between V and F.
So it's just the opposite of it?
Yeah. Yep, and it's just always the other way from it. So if V and F are 2 units apart, V and D are 2 units apart. It's just the other way. And in this case, other way means left. You'll know whether it's left, right, up, or down based on 2 things. When we get into it, you look at the letter that's squared, and you look at the number right there. If x is squared or y is squared, that tells you something. And then if the 4 is positive or the 4 is negative, that tells you something else. Between those 2 things, you can figure out if it opens up, down, left, or right. All right, so let's, if you take a look at table 1, okay, table 1 in your packet, it shows you all 4 equations. The first one is y squared with a +4, then you got y squared with a -4, then you got x squared with a +4, then you have x squared with a -4. That little chart tells you everything that's happening. Okay, tomorrow I'm going to have that chart available for you to use on the test. So you can use that. So far we've done the top one, y squared with a +4. And if you look under the description, it opens right. This is x squared, but it's not quite written with the 4. What would a have to be here? So you would, it would have to be 3. So the negative never goes with the 3. It goes with the 4. Okay? So I'm looking at that. I see x squared. I see a -4. If I look down my chart, what direction does the parabola open?
Down.
Yeah, x squared with a negative, it opens down. Now remember, that number right there is a. How do you know? Look at your chart. The number right next to the 4 is always the a. The focus, all right, opens down. It says the focus is 0, -a. 0, -a. What's my a?
3.
3. So the focus is 0, -3. And I'll put that right here. Focus. Let's see, directrix. Look at the directrix column. What's the formula for the directrix? Y equals A. So I look at mine, y equals 3. You don't even have to memorize, you just got to look at the chart. Vertex, 0, 0. Okay, so directrix, y equals 3. It's going to be up there. Vertex, right where it should be. Equidistant from the focus and the directrix. Okay, this one opens down, but I got to get the right width. What would be a number I could plug in for y to make this problem easy for me to do? I know this is a little different. You're plugging in for y, you're not plugging in for x this time. Yep.
Do 3 again.
You can't do 3.
-3.
You got to do -3. If you do 3, you get an imaginary number because the parabola opens down, not up. 3 is up. Plug in -3 for y. Okay, so we're going to get x squared equals -12 times -3. X squared equals how much? 36. So what's x? Plus or minus 6. So here's your 2 points. Negative 3, 6. Negative 3, negative 6. So negative 3, 6. 1, 2, 3, 6. Let y equal negative 3. So we did everything right. I just interpreted what we wrote wrong. Y is negative 3. X. X is the first number in a coordinate. X is plus 6 or minus 6. So simple mistake, but that will really mess you up. So 6, negative 3. 1, 2, 3, 4, 5, 6. Negative 3. 1, 2, 3, 4, 5, 6. Negative 3. There's your parabola, wrapping around the focus. Any question on that one? Okay, so there's all kinds of ways they can ask these questions, but they're all pretty much the same. Find an equation of the parabola with the focus at 0, 4, and the directrix y equals negative 4. I'm going to graph those two things. Because if I do that, I bet I'll be able to tell which way the parabola has to open, and then I can look it up on the chart. What kind of line is y equals negative 4? Yep. Horizontal. It's a horizontal line right here. My focus is 0, 4. The parabola has to bend away from the directrix and wrap around the focus. So which way does the parabola have to open here? Up. So I'm going to look at my chart. Formula for a parabola opening up is what? X squared equals 4ay. You got to find one thing, a. Well, what do you know about the vertex if you compare its distance to the focus and to the directrix? They have to be the same. There's only one spot in that picture you could put the vertex, and it would be the same distance from the dotted line and the point that I already have. Where would the vertex have to go? It has to go at the origin. And now, remember what we said about how to get A. A is the distance between the focus and the vertex. What's the distance between the focus and the vertex in that picture? 4. So x squared equals 16y. There's your equation. Now, what you might see, probably will see on the test, is they might solve that for y. How would you do that if that's what they asked you to do? Yeah? Yes. So if you get that as an answer, which is how I always do it, I always use the chart, but then they rearrange it and get a letter by itself, that's how you would get y by itself. Because if you were going to put it in your graphing calculator, that's what you'd have to do. You're going to get y by itself. Any question on that? All right, let's try this one. So find an equation of the parabola where the vertex is at the origin. Okay, vertex is at the origin, so I got that. And the point negative 1/2, 2 is on the parabola. So I put that. Okay. Just based on those two pieces of information, the first one and the last one, you got those 2 points. Which way does the parabola have to open? Remember, the axis of symmetry is the x-axis, so this line has to cut right through the middle of the parabola. So you only really have 2 choices, but it's got to open to the left. If it opened right, it would never go through the point negative 1/2, 2. It has to open to the left. It's the only way it's going to go through it. What's my equation for a parabola opening left?
Y squared equals negative 4a.
Y squared equals negative 4ax. Now we got to get A. A is the distance between the focus and the vertex. I don't know the focus. Okay. A is also the distance between the directrix and the vertex. They're the same. I don't know the directrix either. But I haven't used all the information yet. I didn't do anything with these numbers. What is that first number? -1/2. What kind of value is it if you had to assign a letter to it? Yep, that's an x value. What about the 2? It's a y value. So how could you get A in this case? If you know x, or you know a specific x and a specific y. Plug it in. So y is 2. X is -1/2. What's -4 times -1/2?
2.
Yep. So I'm plugging, I'll just show you what I'm doing. Putting that in there, plugging that in there. -4 times -1/2 is 2. And how would you get A by itself? Divide by 2, divide by 2. So in this case, A is how much? 2. Okay. Now I know A is 2. I can plug it in and write the final answer. Y squared equals -8x. Any question on that one? A little different because you had a point you had to plug in. All right, so last problem I'm going to show you. This chart, it's in your packet on page 383. Oh. It's pretty much the same formulas I gave you. Either the y is squared with a +4, y is squared with a -4. X is squared, +4, x is squared, -4. The only thing they add in is this. This allows you to have the parabola shifted, left, right, up, or down. So I said you would know when your parabola has been shifted. How do you know? You're not just going to see an x. You might see like an x minus 2 squared. So if you see a plus or a minus to a number inside h and k, that's the amount of the shift. A is still the distance from the focus to the vertex. That doesn't change. But H and K, those are the only 2 letters, are the coordinates of where you move the vertex to. So we'll do one like that, and that'll be the last one. Okay, so H comma K is where the vertex is. So there's 3 letters you need to find. Still have to find A. You always have to find A. But now you need to tell me H and K. And actually, they give you H and K. Pretty much, as long as you know what you're looking for. What's H? Yep. Yep. What's K? 3. Now A, we got to be careful. A is the distance from the focus to the vertex. Well, you've got the focus, you've got the vertex. If you look carefully, you should be able to figure out how far apart those 2 points are. This one is left 2, up 3. This one is just up 3. Vertex, focus. How far apart? 2. Now, last thing you need to know, great, you've got A, H, and K, which equation do you put them into? Figure out which way it opens. There's your vertex, there's your focus. Parabola has to wrap around it. Which way is it going to open? It's going to open right. That's not an accurate sketch. We just want to know that it opens right. Opens right. Plug every number into that formula. Y minus k squared. Y minus k squared equals 4a. A is 2. So 4 times 2? 8. x minus h. All right, x. Now we got to be careful. How would I write x minus h here?
X plus negative j minus. Maybe x plus 2.
X plus 2. X and y always appear in the final answer. We just had minus a minus. That's why we did that. And that's the equation of your parabola. That's been shifted. Okay. So before the test, if we need to do one more of those, we can. I would focus more on the ones that are at the origin. Those are a little bit more basic and probably more of what you'll see on the test. All right. Okay, so the homework. Okay, 11 through 18, that's all matching. So there's not a lot to do there.
Yes.
19 to 31, that is odd. They ask about the lattice distance. You can ignore lattice stuff. Anything that says lattice, just do everything else it says. Don't do the lattice. And you don't have to do, let's see. Oh, I already crossed them out. Yep. Should be good. Okay, so we'll take a look at that tomorrow.